We have time. We have 15 minutes to open the file. You see the
good morning, everybody. I'd like to talk today about the project I'm working on about infiltrating the treated wastewater in unsaturated soil. First, a short outline. I will say some words about the legal basis about discharging treated wastewater in Germany, the goals of the project, the approaches we use. One of them is to further develop a software tool we already have to implement the wastewater treatment plants and to quantify the water and solid fluxes in the soil with regard to infiltration, storage and filtration capacity. I will show some preliminary results and our conclusions up to now. In Germany, there is no policy for discharging treated wastewater in unsaturated zone, and also we don't have any permit, building permit to install a small-scale sewage treatment plant in the area with no possibility to discharge the treated wastewater in a river or a channel. Here's some way to install this small-scale treatment plants to sample and how it looks like in your garden. The goals of the project is by infiltrating this treated wastewater in unsaturated zone, we can reduce the pollutants through the natural filtering capacity of the soil, and we would like to contribute to the artificial groundwater recharge to improve the sustainability of the groundwater resources in arid areas, of course not in Germany, and to develop guidelines for the disposal of the treated wastewater in Germany and in general in the European Union. Our approach is first to further develop our own software tool called PC-SIVA code. It comes from the seepage water prognosis, and especially for the small sewage treatment plants. This short name is from the German word. And for doing this, we have coupled our program with the FreeC. We extend our wizard modules and we introduce new databases for the wastewater, for the treatment classes, for different soil parameters and sorption parameters. And at the end, we will have a new interface for the data transfer between all the coupled models, and we do the verification and validation of real-world cases. So to quantify the water and solid fluxes in the soils, we conduct column experiments in which we study the soil water content and the degradation of the wastewater components under different environmental conditions. And we have simulated the 1D and 2D experiments with our model. We also perform a sensitivity analysis to account for the spatial and temporal variability of the infiltration source. So our problem is that there are many small sewage treatment plants in the remote area, and if you want to build one and you don't have a connection with a channel, you don't know what to do with your wastewater. This wastewater is treated, and the main idea of the project is that we can reuse the treated wastewater for the groundwater recharge. So we have our model. It's a 1D, 2D finite element model for that saturated zone, which you can simulate the flow and solid transport. We have coupled this model with FreeC to account for the geochemical redox reaction, precipitation in dissolution, and microbiological transformation. This model is also coupled with a 3D groundwater model to account for the water and solid transport in saturated zone. And to account for the atmospheric conditions, we have further coupled our program with a weather generator. We have implemented different databases, a soil database, sewage treatment plant classes database, and we have further our chemical database to include all the contaminants for the wastewater and to include more reactions. Very short overview, I'm sorry it's in German. So this is how it looks like our databases. We have a contaminant database, we have a soil parameter database, soil mechanics database, sink and sources database, boundary condition database, and so forth. So, short overview about our program. Simulates the water flow and solid transport in unsaturated zone. It is based on SWMS 2D, and the mathematical background is the usual one. It's based on the Richards equation for the water flow in 2D, the convention dispersion equation for the solid transport. It's a window-based interface, has an interface with the geological borehole database, specifically for Germany. And we have a weather generator. It's online linked with the meteorological weather stations, and it's coupled with the fixie for the biogeochemical reactions and with the groundwater model. The most important databases are for the soil, for the contaminants, and for the sewage treatment plants. Has a large range of publications like remediation of contaminated sites and landfills. Landfill covers, like for example, capillary barrier and recultivation layer, damp flow, agriculture, mining areas, and of course the small sewage treatment plants. And another overview, how is the model set up? So you have your case description, your units, you can choose different modeling options. Like for the flow, you can choose different transient flow or parameter identification. You can choose your coordinates. For the solid transport, you have one or more migrants or contaminants. You have different information about the contaminant. You have organic, inorganic groups, and you have the link with fixie. This is still in work. Here we have introduced different classes for the small-scale sewage treatment plants according to the German law. And if, of course, you have the possibility to do your experiments in the field or in the lab to choose your parameters, this is very nice. But if you don't have this possibility, you can choose your parameters from the databases. These databases are also one of them is according to the German law, and you have all the possible soils you can find in Germany. And we also introduced specifically for our project a new database for the soil we use in our project. When you like to choose your contaminant, you have different possibility, organic or inorganic. You can choose from a large range of contaminants. Most of the parameters are from the experiments, also from the literature, so you can choose anything you want. And you have your model geometry. You can also, so it's a finite element. And then you run your program, and here you get an overview how your water content is behaving during the simulation, how the concentration is looking like during the simulation. And because in Germany we have drinking law which tells you which is the limit, the upper limit of your contaminants in the groundwater. We introduce what's called here limit for each contaminant. So you will know during the simulation if your concentration is beyond the legal limit or not. And at the end, because this program is meant mainly for the engineering companies, you will get an A4 report which tells you about your wastewater prognosis according to the wastewater law. And you have again your input data given here, your material parameters like soil parameters, contaminant parameters, and you got two graphs about how your concentration looks like at the end and how is the fraction. And of course it's telling you if your concentration at groundwater is beyond or below the legal limit. In parallel with further developing of our model, we did column experiments in which we infiltrate treated wastewater through a 1 meter column, and at the bottom we collected this water and we analyzed it for different parameters. We had several locations, but only 3 we studied in the end. And there are one coarse sand and gravel, weak or slightly weak silty sand, and medium sandy silt. And here are the parameters measured in the lab, and this is what comes out the outflow. And here are the last column, you see that some parameters are above the legal limit. So for example, nitrate and ammonium and so on. So these are the results obtained in the lab, and we observed that ammonium reduction was in all soils possible, but due to the nitrification we had an increase in the nitrate concentration in all the columns. And for the phosphor reduction was inhibited in the first 2 soils, but in the last soil, which is medium sandy silt, was much better. These columns are still running, so it's not ideal. Also, we did sort of preliminary simulations with our program to see how the water saturation behaves in the these are the first 2 sands I showed you, so weak silty sand and coarse gravel sand. And here you can see an hourly water saturation for the both sands. And we also had continuous infiltration of about 400 liters per day for the free sands, and we also simulate the sulfate concentration after 1 week. In parallel, we did a series of sensitivity analysis. In this case, we used precipitation and different groundwater levels to see which parameter is more sensitive. And the precipitation values we took for from the closer weather station called Görlitz. And this we did it by using the synthetic data generated by weather generator in our program for a data series of about 10 to 20 years and a minimum annual precipitation of about 676 kilometers. And here you can see the groundwater recharge and the precipitation, and for the free sands, so the medium sand has a peak in the very beginning, this is peak precipitation, and without precipitation it's here at the bottom. And the other 2 sands are growing steadily and having a peak after 700 days. So until now, what we were able to observe in the lab is that the sufficient infiltration capacity for the soils with the Graeber for larger than 10 to minus 7 meters per second. And one column from Klein outputs that the medium sandy silt show good degradation for all wastewater components, and that the different environmental conditions, for example 10 degrees or 25 or 30 degrees, didn't have any significant effect on our column experiments. We didn't observe any blocking, and we had we observe similar results in the simulation we have done. What needs to be, or what is actually now done, is the verification and validation of the real-world examples, because what we did now is just our simple lab and field experiments. So thank you for your attention, and if you have an interest, we have some.
Okay, before the break we have some questions.
We should mention the break.
Yeah.
So if you don't have any questions, you can have a handout and you can contact us later.
I have a question. Have you tried to do some comparison with the, I don't know, one of the components from Hydrus?
Yes, we are doing Prague instrumentation.
So you're using your model and Hydrus and compare the results?
Yeah, sometimes. For some cases we do this verification to see if our results match with Hydrus.
What is the main advantage to use this model?
The main advantage are the databases. So if you don't know what your parameters are, so you can, or you don't have the money to do the experiments, then you just use the databases.
How long does the model development take? How many people does it develop?
Well, actually, this model was started about 15 years ago. That's why it's based on SWMS. And actually, we are a university, so it's only one person doing most of the things. So we are at the time we had 2 people, but whatever you saw here, it's my work.
So 15 years of development.
Yeah, but you started from practically.
Basic things.
Yes, and then it developed in time. And because we are working with the companies, they also tell us their wishes, what they would like to have, what we have to improve, so we do that.
Well, let's go to drink coffee.
Yes.
We're missing just one thing. During the coffee break, we have to take out the posters, take it down. So there is a last chance to see posters and the authors. I would like to ask them to take it off before next.
Yes.